Hello everyone. Today we are talking about Lewis structures. Today your topic is Lewis structures. Your goal. I can find the number of valence electrons of each element and draw their Lewis structure. So first, in order for us to know what a Lewis structure is, we need to talk a little bit about the periodic table and electrons. So the periodic trends that we talked about in the last section are linked to the ways electrons fill energy levels. So remember, for each proton in an element, you have an electron. Therefore, as the atomic number increases, so does the number of electrons. So to understand the trends, we use the Bohr-Rutherford model of the atom that we talked about when talking about the history of the atom. So first thing we need to know for this is the octet rule, which says atoms tend to gain, lose, or share electrons in order to acquire a full set of valence electrons. So a full set. If this rule is called the octet rule, how many electrons do you think it needs in order to be happy or full? It is 8. So these elements want to be full and in order to be happy. And in order for them to be full and to be happy, they need 8 electrons in the outermost shell of the atom. So the outermost shell of the atom, what is that? What is that talking about? Well, that is valence electrons. They are the electrons in the outermost energy level of the atom, which is the energy level farthest away from the nucleus. So it is outside the atom. It is the farthest out you could possibly go within that atom. So when chemists study chemical reactions, the only thing that's changing and happening has to do with the valence electrons, or the electrons in the outermost shell, or farthest away from the nucleus. So valence electron trends. As you go down a group or a column, the number stays the same. As you go across a period, it increases one by one. Now we are ignoring transition metals, and we will talk about that, transition metals and valence electrons, in the next unit. So, like I said, you have your first column right here. So this first column, you have one valence electron. So if I were to ask you, how many valence electrons does hydrogen have? It's 1. If I were to ask you how many valence electrons potassium has, it's 1. Francium has 1. So if it's in this first column, it has 1. It doesn't change. If we go to the second group, it has 2. So beryllium has 2 valence electrons. Calcium has 2 valence electrons. All of these right here, it doesn't matter how far or how low, they have 2 valence electrons. Now we are skipping the transition metals. So let's move on to this column. It has 3. So boron has 3. Aluminum has 3. And you guessed it, gallium also has 3. Everything in this column has 3 valence electrons. Brings us to the next column, it has 4. So everything in this column has 4 valence electrons. The next group, if you can believe it, has 5. So nitrogen, phosphorus, arsenic, they all have 5 valence electrons. The next group is 6. So your oxygen, your sulfur, your selenium, your tellurium, they all have 6 valence electrons. Then the next one, I know it's a shocker, they have 7 valence electrons. So your fluorine, chlorine, bromine, iodine, all of those have 7 valence electrons. And then your noble gases have 8. Now, if you remember, we said in order for them to be happy, they need to have 8 valence electrons. So that's saying all of these right here in this last column, they already have 8. They're already happy. So that's why noble gases don't like to do anything with anybody else, because they are happy with themselves. Wow, that got kind of deep. All right, so why we need to know. Valence electrons decide which elements can bond. The magic number of valence electrons is 8. So, like I just said, these valence electrons, that's what causes every chemical reaction. They're trying to bond, they're trying to react in order to be happy, in order to have 8. And those noble gases are already happy, so they don't bond or react with anything. So, in order to visualize what valence electrons look like, we have structures called electron dot structures, also known as Lewis structures. And it has the element symbol, which represents the atom's nucleus and inner electrons. And then surrounding the symbol, there are dots representing the number of valence electrons of that element. A person called G.N. Lewis devised this way of teaching in 1902. So you do need to make sure you need to type this out in your notes section. So here are the steps. You do need to type these steps out so you know how to do it, and then we will do several examples together. All right, so first off, you write the element symbol. So for example, let's just do sodium. So I have sodium, Na. Na. Make that a little bit bigger. Find the element of the on the periodic table and notice the group it's found in. So if we go here, we find Na. Well, that's in this first group. So that means it just has 1 valence electron. So number 3, calculate the number of valence electron it has. 1, because it's in the first group. Okay. Write the symbol and place a dot next to it for each valence electron. So we insert a shape and we will do a circle. So you start on one side and you draw a circle for an electron right there. Now, sodium only has 1, so we only need 1 dot. Now, let's do another one together. Let's do aluminum, Al. So if we go back to our steps, we need to find it on the periodic table. Aluminum is right here. So if you go up, it is 3. It has 3 valence electrons. So insert, shape, a circle. So you have 1. One thing you need to know, you can have up to 2 on each side, but you have to go in a circle motion before you put them side by side. So add another circle. 1, 2, 3. Well, aluminum only has 3, so we stop there. So what happens if we have more than 4? So let's do one more example. Let's do oxygen. O. The symbol for oxygen is O. I'm going to move it down. There we go. All right, so to make it easier, I'm just going to copy and paste these circles. All right, so if we look at the periodic table, oxygen right here has 6 valence electrons. So we need 6 circles. So we'll put 1 here. We go in that circle rotation. 2, 3, 4. And you just keep going in a circle. You can have up to 2 on each side. 5, 6. So that is what the valence electron for oxygen looks like. So here is an image that shows what it looks like for each side. It doesn't matter which side you start off with. I always start on the right side just because that's how my mind works. If you want to start on top, you can, and just keep going in a circle till you have the number you're supposed to have. That's fine.